In this video we'll look at the combustion of hydrocarbons. So we know that hydrocarbons are compounds that are made of only carbon and hydrogen atoms. So if we first look at the combustion of carbon, when it combusts reacts with oxygen, the diatomic element, to produce the oxide of carbon, carbon dioxide. There is another oxide of carbon possible, we'll look at that later. Hydrogen, if we look at the combustion of hydrogen, the element, hydrogen is diatomic, it reacts with oxygen, another diatomic element, to form the oxide of hydrogen, water. Now if we balance that equation, two oxygens, two hydrogens, so that's our balanced equation for the combustion of carbon, the combustion of hydrogen. If you take a hydrocarbon, the hydrocarbon contains hydrogen and carbon atoms. So when a hydrocarbon combusts, the hydrocarbon reacts with oxygen to produce both the oxides of hydrogen, water, and of carbon, carbon dioxide. Now, first of all, we can look at complete combustion. Now, complete combustion is when you have plenty of oxygen in the form of air, so you've got a plentiful air supply, plenty of oxygen around. It is not limited. When you have plenty of oxygen, you get full oxidation of carbon and hydrogen. You get water and carbon dioxide produced. So any hydrocarbon, let's just say for now an alkane, when an alkane reacts with oxygen in the combustion product of our alkane, which is a hydrocarbon, are carbon dioxide and water. Okay, let's have some examples. So our simplest alkane, methane. If methane reacts with oxygen, we will produce carbon dioxide. And water, if there's plentiful air supply, so we've got lots of oxygen, we fully oxidize our carbon. Symbol equations, methane, we know that meth means one carbon, ane means it's a saturated hydrocarbon, so it contains no double bonds. We know the formula for alkanes, general formula, CnH2n plus 2. Meth means one carbon, double it gives me 2, add 2 more gives me 4. So methane is CH4. It reacts with oxygen, which is a diatomic element, to produce carbon dioxide, CO2, and water, H2O. Balancing this equation, will give us our balanced symbol equation. So one carbon, one carbon. The number of carbons in our alkane will determine the number of carbon dioxide and molecules or moles that we produce. Number of hydrogens in my hydrocarbon, halve it to give me the number of water molecules I'll produce. Now if I add up the total number of oxygen atoms on my product side, I've got 2 in 1 molecule of carbon dioxide and 1 mole of carbon dioxide, and I've got 1 in each of my 2 water molecules. That gives me a total of 4 oxygen atoms or moles of oxygen atoms on my product side. They come in pairs, so halve it. 2 oxygens. Now, let's do another little example. Let's try for ethane. So ethane, I'm not going to bother writing out the word equation because I'm lazy, but it would be ethane plus oxygen reacts to form carbon dioxide and water. Just, there it is. Hooray. Now for the symbol equation, ethane. Eth means 2 carbons, double it gives you 4, add 2 more gives you 6 hydrogens. It reacts with oxygen to make carbon dioxide and water. Balancing it, number of carbons in my hydrocarbon will determine the number of carbon dioxides I produce. Number of hydrogens in my hydrocarbon, halve it, will give me the number of water molecules I will produce. Add up my total number of oxygens in my combustion products. I've got 2 oxygens in each of my carbon dioxides, and I've got 1 oxygen in each of my 3 water molecules. That gives me a total of 7 oxygen atoms on my product side. Half of 7 is 3.5. So 3.5 O2s would be required. Now you can leave it as that if you're not happy with half an O2 molecule, because technically we're saying 3.5 moles of oxygen. You can, if you don't like the half, double the whole equation. So 1 is doubled, 3.5 is doubled, 2 is doubled, 3 is doubled. So the whole number ratio for the complete combustion of ethane would be 2 ethanes plus 7 oxygen molecules makes 4 carbon dioxide molecules and 6 water molecules. Both are correct, they are both balanced, but you cannot round, because if you start rounding any of these numbers, you're not going to have the correct balancing. At GCSE, most people prefer whole numbers, but don't forget, we're not saying just 2 molecules of ethane reacting with 7 molecules of O2. We're saying 2 moles of ethane reacts with 7 moles of O2. We can have half a mole, we can have any fraction of a mole. So this is the simplest the simplest molar ratio. 1 mole of this, 1 mole of ethane reacts with 3.5 moles of oxygen to make 2 moles of carbon dioxide and 3 moles of water. Okay, so that's complete combustion, where we produce carbon dioxide and water. Happy days. Sometimes we don't have a plentiful supply of oxygen. Instead, we may have a limited supply of oxygen. If we have a limited supply of oxygen, a different type of combustion will take place. So limited oxygen will lead to incomplete combustion. And our alkane will still be reacting with oxygen, but there's just less of it around to fully oxidize, to fully, completely oxidize the carbon atoms. We always produce water, but instead of carbon dioxide, we produce carbon monoxide, and we always get water. And we'll do a couple of examples here. Methane plus oxygen. If there's not much oxygen around, we might get carbon monoxide in our incomplete combustion, and we'll produce water. Symbol equations: methane CH4, oxygen O2, carbon monoxide, capital C, capital O, 1 oxygen with the carbon, and water H2O. Balancing this equation: 1 carbon, 4 hydrogens, 2 waters. 1, 2, 3 atoms or moles of atoms of oxygen, halve it, 1.5 O2s. If you wish, you can double the equation if you prefer integers. If you prefer whole numbers for your balanced equation, both are correct. If I just sneak in my previous complete combustion for a moment, we can see that indeed, just comparing 1 mole of methane combusting completely to 1 mole of methane incompletely combusting, we can compare the complete combustion, 2 moles of oxygen with 1 mole of methane. With incomplete, I have half a mole less. So there's less oxygen available to fully oxidize the carbon. I'll do one more example of producing carbon monoxide. So let's go for ethane. So again, ethane reacting with oxygen would produce carbon monoxide and water. I won't write it out again. Ethane reacting with oxygen to make carbon monoxide and water. Balancing, 2 carbons, 2 carbon monoxide, 6 hydrogens, 3 waters. 1, 2, 3, 4, 5. 5 oxygens on my product side, halve that, 2.5 O2s. Again, if you want to double that, feel free. I'm not going to. If I just pull back this complete combustion equation, we can see, yes, there is less oxygen required for the incomplete combustion than the complete combustion. That's not the whole story. When there's limited oxygen, we get incomplete combustion. Now, depending on how limited the amount of oxygen is, there may not even be enough oxygen to produce carbon monoxide. We could also get carbon, so just carbon. So the alkane can react with oxygen to form carbon. We normally call carbon soot. That's its name on the street. A very sooty flame has an awful lot of incomplete combustion. The more incomplete combustion there is, the more orange the flame may be. Complete combustion, almost invisible, a non-luminous blue Bunsen burner flame, for example. The reason the roaring flame is all complete combustion is because you've opened the air hole, you have pre-mixed the methane fuel with oxygen from the air, which is why there is plentiful oxygen in the Bunsen burner when you have the air hole open for the roaring flame. The more yellow the flame, the more incomplete combustion there is. Anyway, I waffle too much. Let's have a little look. If we have just completely incomplete, if that makes sense, so the most incomplete combustion possible, methane would react with oxygen to make carbon and water, and our symbol equation would be methane plus oxygen makes carbon and water. Let's balance it. Number of carbons, number of carbons, number of hydrogens, halve it to give us the number of waters. 2 oxygens on this side. Oh, there we go. So I need to put 1 number 2 in. Even less oxygen required or needed when there is not enough oxygen around. If I now just have a little look at ethane, again, ethane would react with oxygen to make carbon and water. If there is not much oxygen around, there's a very limited supply of oxygen. Ethane reacts with oxygen to make carbon and water. Number of carbons in my hydrocarbon dictates the number of carbon, the number of moles of carbon I produce. Number of hydrogen atoms in my hydrocarbon dictates the number of water molecules. I've got 3 oxygen atoms or 3 moles of oxygen atoms on my product side. Halve it. 1.5 O2s. You could double that as well if you wish. Now, we don't know when we combust something exactly what's going to take place. If we ensure that there's plenty of oxygen, we will get complete combustion and we will produce carbon dioxide and water. If there is limited oxygen, we will get incomplete combustion. And incomplete combustion will produce carbon monoxide and or carbon. You may be asked to write an equation that contains carbon dioxide and carbon monoxide, or carbon and carbon monoxide, or maybe all three of the carbon containing combustion products. I don't like that, because unless you know the ratio of the production of each of them, you're just guessing, and a good chemist doesn't just guess to the ratio. So a horrible example that you could get could be something along the lines of octane incompletely combusting. Now, if you were asked to write incompletely combusting, sorry. If we were asked to write an equation for octane incompletely combusting, you could just say octane plus oxygen makes carbon monoxide and water. Whether it's a word equation, a symbol equation, and then balance it. Or you could go for just producing carbon as your carbon containing combustion product. You could get nudged down the road where it would say something like producing equal amounts of carbon monoxide and carbon, for example, in which case octane, C, 8, double it, 16, add 2, 18, reacting with oxygen, O2, to make, now, carbon monoxide and carbon, and always water. We've been nudged in this question, producing equal amounts of carbon monoxide and carbon. 8 carbons in total. I'm going to split it in half to produce 4 of them and 4 of them. Now, depending on the question that you're given, you would have to manipulate the ratio of carbon monoxide to carbon, or whatever other carbon containing combustion products they've told you about. Number of water molecules is nice and easy. Half of 18 is 9. Now I can balance my oxygens. 9 oxygens here, 4 more there, that gives me 13. So 13 over 2, you can just write 13 over 2 here if you want to, or you can do 6.5. You can then go forward and double that if you wish. Next video, we'll look at the problems with carbon dioxide, carbon monoxide and carbon